Lads and lassies, today we are building our very own DC motor. Here is an overview of every component that we need. The main shaft of the motor. Laser printed cutouts for the rotor in the middle, and then the yoke on the outside. These will get punched out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 laminations. 1 centimeter high divided by the 16th of a centimeter per lamination. These are the assembly bolts. 4 holes, 4 bolts. Brushes to make contact with the commutator, and brush holders. Here's just a look at the model number. Magnet wire, 1 pound, 24 gauge. 2 bearings, 3D printed rotor bobbins, 3D printed outer pieces that will provide stability for the whole apparatus. Copper tape that'll be used to assemble the commutator. Well, I'm not sure what these guys are for yet. The metal that's being used here, it's silicon impregnated iron or steel of some kind, the front and the back, and I'm going to flip it. It's a slightly different reflection now on the side of the stack that I flipped, where this side over here does not have the same reflection as this side over here. We need to make sure that they're all lined up in the same direction when this motor gets built. I'm actually going to take every single one of these and do a little F on the front so I can keep track. I'm going to punch out all of our laminations here. You'll just have a little bit of a bend, rotate them out, and they're keep bending, and we'll break the metal apart. And now you can have our first look at what the yoke's going to look like. Now we're going to punch out the rotor in a similar fashion. Just push it on through. 2 useful parts, the yoke and the rotor, also known as the armature. And this guy is just useless. Put all of our rotor pieces onto the shaft. So I found it easiest that we've got this little key to kind of slide that into the key opening in the shaft first, and then that kind of helps you line it up and slide it back in. We'll take our bobbins here, slot them onto the shaft. Got to make sure to line up the slots on the bobbin with the slot on the rotor. Nice tight fit. Bobbin numero dos. After much pushing and giving her a while, also with the help of this little bearing guy to help push down on the bobbin, got everything pushed together. It's nice and tight between the 2 bobbins here, and I'm a little off center. We'll see if I regret that later on or not. Next, we are on to winding the armature with the copper magnet wire. So this is just a parchment paper, like what you use to bake with. Literally just parchment paper. To slot them into the little teardrops, I found it easiest to kind of pinch that end in there, and then ta-da, you got your slot. And it doesn't have to be perfect, because as you put the windings in, it'll take up that space, the gap in between the paper and the edge of the slot. I also found it very handy to leave one end long, because then when you're coming in with the wire, you have something to push against to be able to get you into that slot. Sometimes you can get a little help by bending up that corner too. Notice that's the bottom corner, because as I'm looping around, that's the side I'm going to need to enter in from. So I was having problems as you do with any spool, as soon as you let off tension off the front edge, the whole thing back spools off. So yeah, this little guy in the back prevents it from spinning freely since it's on the socket here and it's square in the back there. There's a pinch point where it won't really go anymore, and that keeps tension right here. And then I just use a bunch of electrical tape and some screws for these guys. So I'm going to be going from 1 to 5 28 times. Just a note, the short end, that is what I started winding with. That's the one that's buried. That'll be the plus, and the end of the last winding that came out is the long one. That'll be minus, because it's long like a minus sign. All right, the time for the next winding. Going from 2 to 6. So now we've got 2 of the 16, I don't even know, two of the 8 coils done. That's right, 2 of the 8 coils. So we're halfway around the rotor. Started with 1 to 5, then 2 to 6, then 3 to 7, then 4 to 8. Now it's going to go from 5 to 1, and I'm going to make sure to wind in the same direction as I've always been going. So when I went 1 to 8, it was this counterclockwise direction here, counterclockwise, counterclockwise, and now that I'm going 5 back to 1, I'm going to keep this counterclockwise rotation going. Okay, so next I'm going to be getting the yoke laminations put together. So what I'm going to try to do is take the tape here, wrap them up. Alright, I'm just going to send it with that, and hopefully I've got all these corners covered up well enough where I don't cut the wire when I'm feeding it around the yoke here. Alright, one side of the field winding is done now. It's 152 turns. And an important note, when you bring your wire across, go over to the other side. So that if you were to look in from the edge, I wound the coil that's closer to the camera clockwise, and the other coil will also be clockwise when you're looking in from the same direction. So both coils need to go in the same direction. Let's get a winding. 152 on each side. Now I'm going to take some time and figure out how the heck to put on the commutator. Essentially, all these wires will need to be connected to this little copper foil so that as the rotor rotates, our brushes will make contact with each of the pieces of copper foil. Copper tape is going to be the commutator for this DC motor. I've selected a length that I like, made a little accordion of them, and these will be the 8 pieces that I need to put on. Each of these 8 pieces will have 2 of our rotor windings soldered to it. Before you put on the commutator, make sure you have one of these rubber O-rings on. That'll make sliding everything over top a lot easier. Steps for putting the copper tape onto the rotor. Get your piece cut, just about 3.5 centimeters. Remove the backing, and then I take and put it on my fingernail, just like that. and then make room for the foil. Line up the tape. Go a little bit past the end of the 3D printed bobbin there so that we can push it over the edge. That gives us a little bit more strength, and make sure it gets pushed down onto the grooves of the 3D printed bobbin really well. I don't have any footage of this, so basically just adhere 8 pieces of copper foil to the 3D printed bobbins and line up the foil in between each teardrop shaped slot. Now it's time to solder the armature coils to the commutator. So I have coil 8-4 here, which means there's the last coil that I wrapped around going from 8 to 4. The plus of each coil is the short wire. The long wire is the negative because it's long like a dash, like a minus sign. For this 8-4 coil here, the plus, which is the short side, to the H slot on the commutator, and the minus is going to get soldered to A. Here is a reference of how to solder the commutator to the windings on the rotor. So you can see in the middle we have A, B, C, D, E, F, and G. Those represent the 8 little copper foil pieces that we have as the commutator. And then the colored lines of blue, red, green, and purple are the individual windings that we have on the rotor. So supposedly the enamel on this magnet wire, the copper wire here, is supposed to come off with heat. I didn't find that to be the case at all, so I'm just taking some flush cutters here and scraping away the enamel so we can have some nice contact. Now we're going to move on to 7-3 coil, and the short end, the plus, is going to get soldered to G, and the long end, the negative, is going to get soldered to H. So the positive of 8-4 is going to share with the negative of 7-3. There it is, one commutator, completely made. I'm going to go ahead and clean up this mess, so I'm going to try to keep the long ones are going to stay longer, and the short ones are still going to be short. So now I'm going to be taking our brushes and soldering on some length of wire so that we'll be able to hook up our battery to the brushes. There we go, one brush done, another brush also done. Next I'm going to start assembling the housing. In my infinite wisdom, I also did not take any footage of the assembly here. So basically you'll take your 2 outer pieces, the big black outer pieces, take your rotor shaft that already has the bearings slid onto the shaft, slot those into either 2 holes, and push the whole thing together with your long black bolts. Be careful not to make it too tight, because otherwise there's too much pressure against the bearings and the electromotive force is not enough to overcome pressure and allow the motor to spin. Then also you need to get your brushes assembled and then just slot those in with those 2 little screws. Hopefully the videos near the end here will be enough description to show you how the rest of the motor gets put together. This is my first test to see what happens. First test. Oh, it does something, but then it stops. What happened is that the brushes need to be 90 degrees offset from the windings on the yoke. So now, when we're hooked up in series, so the field winding is hooked up in series with the rotor, we get a pretty good movement out of her. And then if we wanted to have even more gusto, we can hook this up in parallel with my power supply, my 12 volt 10 amp power supply. So now we're in parallel and we can really give her the beans.